I would very much like to welcome everybody, the presenters and the attendees, to this third Autonomous Ship Reality online event, in which we have prepared a very nice set of experts and presentations in order, once again, to touch upon issues related to the autonomous shipping, autonomous operation on board, and this type of operations. So I would very much like to welcome everybody. And very, very quickly, let me say that my name is Nikolaos Bedikos. I come from the National Technical University of Athens, schools of Naval Architecture and Marine Engineering, and I will be presenting and moderating this very interesting event. Then we will continue with Maxime from Marinet. The floor will be taken after Maxime from Jorge from Fundación Valencia Port. We will continue with our fellow Greek, Matthew Macheras from Metrostar, and we will conclude with Elena from Civility. Again, I think Elena has prepared something on the Moses project. At this point, I would like to mention that this session is organized by BS Group. Thank you, BS Group. As the session sponsor is Maritime Organization, and we would like also to thank Marinet for their kind contribution. So, not losing any more time, I think that I will be taking the floor in order to begin with my presentation. I don't know, can somebody verify that you can see the presentation of my presentation? Is it up and running?
Yes,
Very
yes,
nice,
up
very
and
nice.
running.
So I would very much like, if it's possible, for all presenters to switch off their microphones for any background noise. Thank you very much. And I will take the floor for the next 10-15 minutes to discuss about the determining of the requirements for fail-safe design of autonomous ships. So we will be talking about the fail-safe mode. And the focus is on some work done on the Moses project on what we call the autonomous tugboat swarm. Okay, the fail-safe principle is particularly important for autonomous systems with high level of automations and low level of human involvement. We must have some stage where we know that our system will balance if something goes wrong. The classification societies have highlighted exactly the necessity of integrating fail-safe functionalities to autonomous ships. You can see references from DNV, BV, and ABS. And fail-safe, as we understand, is a design strategy that aims to make the behavior of autonomous systems more deterministic in some, let's say, unpredictable environments or in some emergency states. So our aim at the Moses project was to determine the fail-safe requirement for maintaining the safety of the swarm and maneuvered vessel. We had a swarm of tugboats that they were trying to make the last maneuver part for docking and undocking of a big mother vessel, a big container ship, and of course preventing the escalation of hazardous situations. So first of all, some terminology in order for us to understand and to have a common terminology. What's a fail-safe? What's a fail-safe principle? A single point failure or the disruption of any of the system functionality result in operational conditions that prevent potential damage and or harm. So a fail-safe situation is where we have these operational conditions that we are certain that they will not lead our system to some damage. From fail-safe, we can move to what we call as minimum risk condition, MRC, which is the state that the ship should enter when the auto-remote infrastructure experiences situations that are outside those in which it can operate normally, but it is still expected to deal with it in one way or another. And this is according DNV. So we have the operational envelope of the vessel according to Rodseth in 2021. Then if something goes wrong, we should be able to move to the fail-safe space. And if this is an unwanted situation, we cannot keep in the fail-safe space, then we move to the unwanted accident space, which we want to avoid, as we all understand. So the methodology that we used, first of all, was adapted from DNV's guideline. So we had to identify the scenarios, what could go wrong in our autonomous tag swarm. Then to identify the minimum risk condition stage and ranking by priority to see where we are aiming at. To determine the feasibility of this MRC stage for each scenario. And finally, requirements for the MRC implementation in order to be able that we will be certain that we can achieve this MRC stage. On the right-hand side, you can see the initial figure from Leveson from MIT, which had to do with what we called as STPA, the system theoretic process analysis. And why do we use this one? Because many applications in autonomous ship concepts already has been working with that. You can see various publications. You can also see one of ours back in 2020. And second, it's one of the most promising methods for the application of autonomous systems altogether, but in this case, on autonomous ships in particular. So what we needed, first of all, we needed, as you can understand, the development of the tugboat architecture, of the architecture of the system. On the right-hand side, you can see the relevant figure where the blue line, let's say, puts the boundaries of the system. So the tugboat, more or less, is the blue line. The green dash line is the detection mode. So it's where you integrate the various sensors like LiDAR, like AIS, etc., etc. The purple dash lines frame the area with the path planning module, where we have the AI algorithm that decide how the tugboat swarm will move, and the control module is actually where the actuator lies and the various propulsion system of the tugboat lies, is being framed by the reddish dash line. So we can see that somewhere there is also the captain, where he can have an intervention role if should this be necessary. And as you can see, the captain on board should monitor the operation. The remote control center of the tugboat operator should change the autonomy level to initiate the operation. Then control of the maneuver vessel should always be maintained. This is very, very important. And appropriate actions in case of off-nominal situations should depend on systems operational status and external conditions. So what you need in this methodology to define is the losses, is the hazards, the system level hazards, and of course, the system level constraints. So you can see here, for example, that the swarm must control the speed and position of the maneuver vessel within acceptable operational limits. This is a constraint. This constraint can give to a hazard like swarm does not control the speed and position of the maneuvered vessel. And this hazard can escalate to various problematic situations, to various losses, like loss of life or injury to people, damage to the maneuvered ship, or damage to the tugboat. So in this sense, we have various levels of the escalation of the problem. And what you need in order to implement the STPA method is actually to have a control structure diagram. So you can see that it goes from the maneuver vessel to the shore tugboat control station. In between, there are various levels and events and safeguards. And you can see that with a dash line is the information flow where where with the solid line we represent the actual control and actions. Now you can see that we have a swarm comprising two tugboats. So on the left-hand side, we have the structure for the tugboat captain and the tugboat number 1. And on the right-hand side, we have the tugboat number 2, where we have the role of the tugboat captain. We have how we can accomplish the path planning module of the second. And you can see lower down to the detection module of the second and the control module of the second tugboat of the two comprising the swarm. So we have the control structure diagram, and then we come up with various loss scenarios and causal factors. In our case, we developed 21 loss scenarios, which were identified and classified per module. And you can see the structure and how we get them. We have, for example, loss scenario number 1, where the control center does not provide the switch autonomy level command to the path planning module due to loss of wireless connectivity. So this is an unwanted action, and the causal factor here is connectivity loss, or latency. It's going less with a less speed than the required. Or you can see the loss scenario number 8, where the path planning module does not receive data from the detection module, like sensors failure or some kind of other failure. This is another unwanted activity. This is on 4, and the causal factor is sensor failure and maintenance. So in this way, we have come up with 21 different loss scenarios. On the right-hand side, you can see that the scenarios were classified, for example, per module and causal factor, and you can see that the most, let's say, frequent factors were the sensor failure or problematic maintenance, cyber attack, and connectivity loss or latency. And in general, we had from the scenarios, 43% of the scenarios had to do with technical failures like actuators, sensors, etc., and another 43 had to do with cyber attacks, connectivity, and this kind of stuff, which it seems this 85%, it seems that it gives, the pointers of what we should be looking for in these cases. Then what you do with STPA, you identify and rank the various MRC states, and you can see that we have identified various MRC, minimum risk condition states. For example, the manual control takeover in case of an emergency from the tugboat captain. So the tugboat captain disengage the autopilot on all tugboats and manual navigate them. So the whole swarm becomes a manual and a conventional fleet of tugboats. The mission is completed by the captains on board the various tugboats. In our case, there are 2 separate tugboats. Another minimum risk condition case could be remote control by the remote control station of the tugboat. So the mission is completed by the shore tugboat control station operating remotely. And you can see the other MRC that we had identified. For example, MRC 1 had to do with a hot swap. So in this case, the remote operator holds the swarm operation, and the mission is completed with some delay, of course, but how? Autonomously after the malfunctioning tugboat is being replaced by another member for the swarm. So the implementation of each MRC state is connected with various functionalities. And we can understand that the MRC, as we have put them, they gain as we go towards the lower rows of the metrics in autonomy. So these MRC states are ranked by preference from the least to the most preferred solution, and the most preferred solutions mean the solution with a higher autonomy. In our case, that's why I mentioned hot swap, because you change the problematic tugboat, and you continue with the full autonomous operation. we must combine now the various loss scenarios in the STPA methodology with available system functionalities. The functionalities has to do, for example, with tug-to-tug communication, with the detection module of the first or the second tugboat, since they formulate the swarm. The control of each of these tugboats is also an available functionality. And on the right-hand side, we can see when we have the red points, which means the red cells, it means that they might be problematic. So for the loss scenario number 1, we have problematic, it's the autonomy level switch, so they do not switch into the autonomous operation from the remote control center. There are problems in communication. So if you have that, the MRC state, the minimum risk control state, is to get to a manual takeover, so everything will be done manual in order to avoid the problems on the functionalities as these are given by the red cells. In this case, and when we have done that for all the various loss scenarios, you can see that we have a lot of MRCs of 2, of 3, and 4, whereas we note that the MRC number 1, the hot swap, was not associated actually to any loss scenario, to the failure types that we have considered in analysis. So at the very end, we have not taken into account MRC number 1. So this led to about 52% had to do with the manual takeover as the MRC state, 24 pointed towards remote control, and 24% pointed towards what we called shared situational awareness. So in that sense, the situational awareness came from various means in order for the autonomous swarm to continue to operate. And when this comes along, then we understand that we go back to, let's say, to the control structure that I have shown previous in the presentation, and we start identifying and adding requirements in order to have, as I said, as a last step, the actual MRC implementation, because we don't need to have that only theoretically, but we have to be able to be certain that when we decide each of the 4 MRCs, that we will be able to implement it in reality. So, for example, we need to share more information, not just for the position, in order to gain the situational awareness information in a better, let's say, in a better form, or we need to have active control in case of failure, not just monitoring when it's failing, but we can interfere. So in this sense, we can have the orange new blocks where they give what we need to add in order to get a better, let's say, situation for the implementation of the MRCs, and the green ones exactly show which of the modules are being affected towards this end. So, concluding, it is important, we all understand that it is important to keep humans in the loop. It's not theoretical. You can see that some of our scenarios led towards either manual takeover or remotely controlled vessels. So it is important to keep humans in the loop, both on board and remotely, to maintain an adequate level of safety in cases when the autonomous tugboat swarm operates outside its defined operational envelope. Operational envelope, it's a very interesting term. It's a term that we will be hearing more and more now that we are dealing with autonomous shipping or autonomous operations on board. Manual and remote control, which are mentioned in the class guidelines, are feasible for this operational context, but states such as moving slowly or aborting the operation, may not be, and this need further study. Future implementation of the fail-safe functionality could be software module that will be integrating the architecture of each autonomous tugboat in the swarm, in the case of the Moses project, which will lead to the definition of the optimal MRC state in each of the scenarios, follow predetermined strategies, navigation, mitigation of failure consequences, in order, we need to develop some library of strategies, and the vessel will be able to retrieve the necessary or the optimal strategy to deal with current prevailing conditions, and provide relevant information to the tugboat captain and to the remote operator through the wireless module. So in order to help to the decision support in a form of a decision support system. Thank you very much for your attention. I tried to go very fast and give you an idea of the various steps that we used, based always on the STPA methodology, in order to define the fail-safe state, the fail-safe operation for the autonomous tugboats in the Moses project. So, as I understand, I will check whether there is some questions, and I will be answering the questions when the second presenter will be on the floor, and he will be Maxim Barkasov, who is a lead expert at Marinet RUT. I have a very brief, let's say, bio before he gets the floor. His center aims to push high technologies for autonomous shipping to the national markets, at the same time working for regulatory development to make implementation of autonomous navigation smoother and efficient. So Maxim has worked as a science working at the Federal Research Center for Project Evaluation and Consulting Services, where his focus was the development of expert system for selection and appraisals of scientist projects for financing. He holds from 2007 a PhD degree in economic, and he got his degree from the Russian Technological University on management. So, Maxim, the floor is yours. Let me see, I have to somehow, okay. So if you can share your presentation.
Yes, thank you very much. I would like to share my presentation. How is it? The slides. Yes. This is probably final slides. This is a circle of the presentation. That's why. Sorry for that.
Okay. Now I think we are there, Maxim. The floor is yours.
Yes. Thank you very much, dear colleagues, distinguished guests. Thank you so much for the interest to autonomous shipping. I would like to express my gratitude to BS Group for inviting me to the conference and make this presentation. Also, I want to add that this meeting is very actual, because during the 108th session of the IMO Maritime Safety Committee, we have a new schedule, new date of the development of mass code, non-mandatory code. Mass code will bring to the experience building phase by the half of 2026. We have a year more for the development of autonomous navigation, and also the adoption of the mandatory code, which will be developed by July 2030, will enter into force on January 2032. That's why we have 1 year more for the implementation autonomous navigation for the non-mandatory code, and have 2 years more for using autonomous starting use autonomous navigation in full mode in the world. That's why I want to cover the one of the additional topic that connected with the training of CFS for the mass operation. Probably this is the nearest future that we need, and we have some preparation for that. Since 2019, Russian Federation has implemented the world's largest autonomous navigation trial project, including both extensive trials in real conditions for mass technologies and the development of national regulation on mass use. Under the Russian government approved in December 2020 was approved government regulation, and since 2021 any shipping company can equip its vessel flying the Russian flag with autonomous navigation system and use them for regular shipping operation as the part of the national experiments conducted till 2025. And also we are waiting for the issues of the mass code of International Maritime Organization. And also it was to know that in July 2023, the federal law in Russia was adopted for regulating legal relation using autonomous ships, and this federal law introduced the changes to the number of national documents aimed to creating a legal framework allowing the operation of autonomous ships, and this federal law is planned to come into force in 2024 this year. And the extension of commercial operation of mass flying the Russian flag and the importance of human elements for safe mass operation require qualified personnel for mass use. That's why it also need in the other countries to meet this need. In September 2022, Admiral Makarov Maritime University in Russia, in collaboration with the other institutions and commercial companies, developed a set of advanced training program for mass personnel based on applicable standards of the STCW Convention and the mass code, and also taking into account the practical experience of mass using in Russia. The purpose of the program is to train masters and crew on board, crew for operation of on board and remotely controlled vessels with the crew on board, and prepare to remote crew to operate fully autonomous vessel. According with the Russian legislation, which was introduced now, remotely control with the crew on board ship can operate it with continuous watchkeeping, control over the ship navigation, ship's engines, machinery, and equipment by the crew, who generally supervises the ship, and if necessary, controls the ship and take measures to restore regular operation of ship equipment. Fully autonomous ship can operate it with the crew on board, with or without continuous supervision by remote crew outside. The Russian approach of mass is based on principle of complete functional equivalence, presupposing the full performance of all these functions control. It based on functions in line with the standards of competence of crew member set out of STCW Convention and Code. I would like to share the structure of the training program, which was developed. The program based on STCW Convention, Federal Law of Education in Russian Federation, and regulation of certification of crew member of sea vessel approved by Ministry of Transport, and also merchant code of the Russian Federation. There are lists of training program. We have a free type of program for remotely controlled vessel with crew on board, for the fully autonomous vessel, and for VTS vessel traffic management personnel. For remotely control, this is a master, officer in charge, management level engineer, office in charge of engineering watch, for electrical engineering, for fully autonomous. Also, we train the GMDSS radio operator and the remote crew engineer. And for VTS, we trained additional operator for traffic management and interaction with the remotely controlled with crew on board and the autonomous ships in the VTS area. This is the a slide about training for master operating remotely control ships. This is additional program. This is advancement program, which based on the common common education, maritime education. That's why for the taking the these degrees, this certificate, we require the experience in a relevant position of the captain in at least 3 years, 12 months, or of which in the last 5 years. This is the professional competence for the master of operating remotely controlled ships. This is the international maritime conventions and recommendation, as well as the national legislation in field of operating of autonomous ship, ensuring appropriate identification of ship's conditions and control in the semi-autonomous mode, providing control in the vessel in remotely controlled mode, and implementing cyber incident preparedness and response activities. Yes, and the training for master of remote operator center. The program also need the previous experience and the thematic plan includes section of theoretical and practical sessions with the automatic control, navigation automation, information technology, and also cybersecurity. And the professional components also include knowing of the legislation, or also remote operation master of remote operation center need to know the artificial intelligence, identification of the state of autonomous ships, monitoring and control the state and movement of autonomous ships, interaction with the VTS, implementation, cyber incident preparedness and response activities, cyber vulnerability assessment, and also implementation of the cybersecurity plan. To support to training process, the proper simulator is developed for simulation of navigation conditions, MAS system, and remote operation center that allows to train MAS personnel for various conditions and scenarios. The first simulator, including VR version, was deployed in Russian University of Transport in 2022. The collision avoidance intellectual system of the simulator based on ColRec 72 requirements and ensure the safe navigation in traffic environments with up to 50 navigation hazards in the AIS control area. The second A navigation and E navigation simulator was designed and constructed and deployed in October 2023 at Admiral Makarov State University. By the end of 2023, the Russian University of Transport successfully trained and issued certificates for 40 remote operation center operator and their masters of remotely controlled ships with the crew on board. And also, I would like to know that in Russian was developed the virtual platform for modeling autonomous navigation. There was a research in based on analysis of AIS data from Baltic Sea and the area over the period of 6 months, encompassing with 20 million positions. Additionally, a survey was conducted with the more than 100 navigators at the management level. The concept of INS quality assessment means solving navigational tasks that may encounter during a mass operation. The assessment can be conducted on a virtual platform for modeling autonomous navigation integrated with a simulator and installed at the University of Transport. This platform allows to testing and assessing of onboard autonomous navigation system in various scenarios and conditions, including congested areas and open sea. The simulator integrated platform is certified by Russian Register of Shipping. And in 20 this is the end of my presentation. I also want to add that universities are ready to cooperate in providing this advanced training program for mass operator as well as the instructors to support the implementation of this program in the country. Additionally, the large number of CFS not involved in a mass operation need additional knowledge about the principles of new technology, and they need the basics of legal relations that arise during the operation of mass to meet the high interest of autonomous shipping and the need for increased awareness. Universities deployed basic course for general understanding mass. Universities are ready to collaborate in developing advanced training program for other countries and to participate in training process. This is the end of my presentation.
Thank you very much, Maxim. Thank you for the interesting presentation. Let me just here say that I just found out the process. You should go to the Q&A under the published tab in order for you to see any questions related to you and your presentation. I just found out that I have a couple for me, so I will be replying in writing in a little while. But before giving the floor to the third speaker, let me just ask you, Maxim, I see a question from Alexandra that it says that the Russian Maritime Authority will be integrated the regulation IMO MAS. And will there be an agreement with South Korea for the usage of this kind of vessels? I don't know whether.
I'm sorry that we have a cooperation with with the Republic of Korea with the international laboratory, but we are talking about the experience in mass only with the Russian vessels. We have now there are 4 vessels operating in Russian Federation. One of that is a dredger caravan. The dredger operated through the remote operation station, which installed in the dredger, and this dredger operated the automatic autonomous barge, which came to um, to go or take over the cargo. Also, we have cargo ships in the Mediterranean Sea. This is a polarized company, and this is there is the ship which connected with the the first trials in Russian Federation. And also we have a new 2 railway a car railway ferry which work in autonomous mode in Baltic Sea. They have a 55 kilometers road, and this is big enough vessel, 20 meters long. It operates in the Baltic Sea and connected. We operated through the remote operation center, which was installed in St. Petersburg, and who are controlled the decision of the autonomous navigation ships.
Okay. Thank you very much, Maxime. Please go to the under the QA at the Publish tab to see whether you have any extra questions on your presentation, and please reply to the attendees asking in writing. And as I said, I will also be doing in a couple of questions that I saw that they refer to my presentation. Okay, thank you very much. And now we can continue with the third presenter. The third presenter is my friend Jorge Miguel Lara Lopez from Fundación of Valencia Port. Before giving the floor to Miguel and to Jorge and to his very interesting presentation, let me just say that he holds a business degree from the University of Valencia and an official postgraduate master's degree in economic internationalization, integration in international trade from the Institute of International Economics of the University of Valencia, and a master's degree in port management, intermodal transport from ICADI Business School. In 2010, he worked at the Institute of International Economics, belonging to the University of Valencia, and with the Valencia Port Foundation as an R&D assistant in projects related to short sea shipping, to logistics and new technologies applied to shipping. From September 2004, he joined the Fundación Valencia Port as a member of the Innovation Port Cluster Development Team, and since then he's mainly focused on sustainability topics, being involved in different projects related to alternative fuels, circular economy, ICT, and sea traffic management. He's an expert in cost-benefit analysis, participating in different proposals for the Connecting Europe Facility framework. He has coordinated the first European circular economy project in ports, the Loop, which was funded by EIT Climate during 2018 to 20, and he's currently Vice Chair of Port and Logistics at the International Research Advisory Group at the Waterborne Technology Platform. Jorge, thank you very much. I guess that we can see your presentation, so the floor is all yours.
Okay, so thank you very much, Nikos. Can you hear me? It's okay? Perfect. Can you see my screen also running?
Everything is fine.
Okay, so thank you very much, all of you. Thank you very much, BS Group, for the opportunity to present this seamless approach and integration in logistic chains. My presentation will be divided in four parts, uh, explaining more or less what is Fundación Valencia Port. Also try to understand how to put in context this autonomous ship in a logistic chain. A brief information about the Moses, that was the previous project that is conducting to the next project that I'm going to explain in depth, Seamless. And finally, I will follow the conclusions. Okay, what is Fundación Valencia Port? Valencia Port is a center for applied research, innovation and training, serving to the port logistic cluster here in Valencia. It is an initiative from the Port Authority of Valencia, and we are bringing together a lot of key companies, universities, and institutions in the port community. We have a lot of topics that we are working on. Currently, we are working in more than 40 projects, and the idea is divided into different areas. In where, for example, autonomous ship, we put this concept in the port logistics area, but also in the digital transformation. Of course, there is a part of security and protection that should be included in. The idea of this presentation is try to explain why it's important to talk about the logistics, because when we are solely explaining the autonomous ship concept, and we are not taking into account the possible solutions into the market. Of course, we are working in early TRLs, but we have to look for the way of implementing these ideas in the future. And for that reason, we have to look for some reasons about why this autonomous ship could fit into a current logistic chain. In this point, I want to highlight that try to put in, autonomous ship in logistics part. There is a clear improvement of the efficiency of the operations. We are reducing the waiting times theoretically, and also we are improving the schedule of the cargo movements. Try to break those limits that are currently ongoing. For example, navigation restrictions, port terminal restrictions, crossing times, etc. In that sense, this point is very important. Also, the cost reductions, mainly in OPEX. Of course, we are talking about a very important CAPEX from primary waste, also for early adopters. But we find very interesting the reduction of the OPEX in terms of personnel, stocks, and storage. Of course, we are in a scenario in where we have to test, and we have to be more safe and deal with liability, etc. And in this point, in a fully autonomous scenario, also in remote control scenarios, we are talking about possible less risk of related to the seafarers on board. Also, we are talking about the more flexibility in the logistic planning and accuracy regarding the predictability. This message is very interesting and is sent directly to the market and to the sector, because this accuracy, this predictability for regular traffic, also when you have to have stable logistic chains, this concept could enrich the idea of flexibility in that sense, and also a better planning on that. Of course, now we are talking about autonomous ship and remote ships, but the idea is we will see in the future that the design of the ship will change a lot, and also we optimize the space. Maybe, yes or not, we will have more cargo capacity, because if we have to deal with the environmental goals, you have to build those ships in terms of sustainable. And the idea of not having so much limits when you are in a fully autonomy scenario, we can adapt better to raw climate conditions and keep safe the seafarers. Also, it's very important to send the message that this autonomous ship facilitates the movement of cargo to close smaller ports, improving the connectivity and fostering real shift of cargo from road to sea. The idea here is that, of course, avoiding these limits, these fences, etc., these barriers, we can take advantage of having this scheme in order to move cargo in another scheme. And the idea is here try to be more competitive and optimizing the resources. The service increase and also the value to the final customer and innovation applications. Saying that, how we started Fundación Valencia Port was participation in MOSES. It is further explained by Nikos, and Elena later will explain more or less about that. But here we were talking about also how to enhance the shore shipping component and try to shift cargo from the road to the sea. And in this project we developed different demos that couldn't reach the idea. But I don't going to spend a lot of time here because there will be an opportunity to explain that. And the idea now is try to explain the ongoing project that we have now. Is Seamless. Seamless is the result of a second level of maturity after the first level of maturity coming from Aegis project, AutoShip project, and Moses project. And the idea in this project, Seamless, that now is ongoing, and it will last 4 years. We started last year in January. We will finish in 2.5 years in 2026. And the idea is here to demonstrate to the transport community that these autonomous feeders that we are building here is can solve the transport problems that they have. We were working in different building blocks. You have the maritime leg or the inland waterways leg. You have also the terminal leg and the hinterland logistic part. In this sense, we are trying to gather everything, try to make a seamless scheme, adding the value of the different building blocks and integrate them with existing results for other projects in order to run to full-scale demonstrations. In this case, apart from that, we are aware that you can run some demos, but we need definitively different transferability use cases. Try to look for the replicability of these seamless business models and assess the impact of the seamless service concept throughout the different regions of Europe. And in that sense, we are working in this scheme. As you can see here, we will have 2 demonstration use cases. We will have one demonstration use case in Norway, connecting 2 main ports, Bergen and Agotnes, with an autonomous ship and the possibility to, from the remote operation control center, to manage or to manage more than one vessel at a time and try to understand what is the logistic behind, try to remove some trucks from that are boarding, that are crossing the fjord and going to another port. And there will be a second one that is run in the inland waterways, also with inland ports and seaports that will run from Lille in France and will connect directly with the port of Ambert in Belgium. The idea here is also taking into account the possible alternative means of transport to move the cargo, and we will see later what we are going to do on this. After saying that, we need to know that there will be 6 transferability cases. taking some of the lessons learned coming from the demonstration use cases that will be run in the Western Europe in a route of Rouen-Le Havre with the inland waterways transport, taking into account the Bar and Ro-Ro cargo, the Central Europe, UK, sources shipping, Port of Hamburg in connection with the Port of Hull in UK, also running with Ro-Ro and container traffic. The Adriatic Sea, try to understand the Ro-Ro concept connecting Piraeus port with the Port of Venice. Another one is the Danube leg that is connecting Galati port, the inland port, and Duisburg port, moving containers and Ro-Ro. The Black Sea leg that we have here connecting the Piraeus port and the Galati port, crossing through the Bosphorus Strait and the Black Sea. Mainly in container, and the transferity case that we are running in Valencia, try to shift some cargo from the road to the sea and connecting several ports along the coastline of Spain and try to reduce the congestion that we could have there. Saying that, in the project, these are the main partners that we can work on this. And the idea is our role here is try to break the building blocks and try to unify them in a specific platform. So with the help of national NTUA in Athens, the university, and with us, we are building the ModalNet platform. The ModalNet platform will follow the European Maritime Single Window scheme, and we are federating or integrating the different platforms that Cosberg is doing from the point of view of the Remote Operation Control Center, the ABSPM that is controlling from Awake, Finland, that they are controlling specifically the port call synchronizations, the BCOP system that is led by McGregor, that is including not only the part of the cargo coming from the ship, but also the cargo that is sent to the hinterland. And in this sense, they are also testing during the project the auto-mooring and cargo handling, etc. And finally, the NTUA, the matchmaking platform that will facilitate to the shippers and the end customers to make the booking about the cargo that we really want to be sent from A to B, in order to understand what are the possibilities from the point of view of the shipper, a real shipper, to move the cargo and try to log all the information that is produced through the systems included in this chart into the ModalNet platform to understand possible delays, to understand if it's feasible or not, if you are adjusting to the main schedule, etc., etc., and also to integrate it in order to show to the market, to the sector, that is possible to include this autonomous ship can be inserted in a supply chains now. Of course, we are working also in seamless, and we have to develop the business models. Indeed, for those two demonstration use cases, we will build these business models, but we are conducting a survey, and we need your help, because maybe some of the people who are now attending this meeting, they are interested in this working. Also, they are thinking about possible business models applied to the autonomous maritime transport. And our idea is try to, through the project, collect using this survey the possible information about the business model, barriers, etc., that could give us an overview of how to go on this. The idea of Seamless is also to be the first project on autonomous ship that could provide a clear picture of how to build these business models, how to make it more transferable, those possible use cases in your companies. In that sense, your views are very important. I will share here this presentation, but you have the QR code as well in order to fill it out. But in any case, I will put it later in the chat. It's very important. Your view is very important, your contribution on this. Saying that, I'm finalizing the conclusions. Why? Why autonomous ship in our sector? Is the technology ready for starting on working on that? Yes, we are progressing on this, but we cannot avoid the conversation or the discussion about why. And to reply this question of why should we put autonomous ship in our logistic chain, it's very important to start working in the possible needs of the sector. For that reason, if there are some shipping companies, sea operators, etc., that are looking at this possibility, we have to be sure that the message that we are sending to them is that we are covering all the parts that make it feasible in terms of implementation of the concept. Because if not, autonomous ship solely, it doesn't mean anything in terms of market. And in that sense, it's very important to state that implementing autonomous ship in logistics chain represent an opportunity, but also a challenge. It's really important to send this message, and we have to build in organically and try to fill out the gaps. Regarding the technology and safety, should be reliable and safe and must be tested for sure. The regulations and legislation should be consistent and clear, not only from the point of view of provide a framework. The regulation is also needed from a commercial point of view. Same rules for all the people, try to ensure that we are doing the same things without problems with liability, etc. The training and education to go with change management, because we are talking about scenarios in where the design of the ships and also in the way in where we are operating the ships will change a lot. Also, the way in where we are serving the ships at ports will change a lot as well. Maybe we are also talking in a scenario in where the whole supply chain is also changing according to these new schemes. So this change management is very important. The autonomous ship must be efficiently integrated into the existing logistic chains. If not, we cannot go to the sector and say, okay, we have this idea, and they can say, okay, you have a very good idea, but the reality is that. Please give me the possibility to enhance my business model in order to insert this concept in my supply chains. And this is the key message that we will hear from the sector, from the market. The interoperability and communication between these different stakeholders are critical. I will say collaborative process, but it's really important because we are sharing information. But we have to look to find the way in where we are sharing the information that is crucial and enough for doing the things. So it's not a question of try to overlap or looking for other alternatives in terms of competence. It's a question of try to collaborate in order to implement really this idea. The market is atomized. There are a lot of stakeholders. There will be, okay, winner or losers from an early scenario, but we have to be able to build a win-win proven business model for everyone. The sustainability and environment is, from the point of operational improvements, is very important. It will increase the capex of the ship, but if this is a model that can be followed in the future, we can reduce this capex. But it's very important when we are talking about sustainability in terms of the autonomous ship. It impacts directly in the design of the ship. The data exchange, really important. We have also a company during the work done in Seamless that will assure that all these communications are cyber secure and they are integrated and they are confidential. And it's very important, this part, because we are dealing with a lot of data, not only from the point of view of the ship, but also from the point of view of the cargo. And this confidentiality and cybersecurity is an issue. And finally, it's an opportunity to implement pure innovation. Here, we are talking about complex environments. Logistics is not an easy, journey, and the idea is the innovation here is key, and there is an opportunity for that. And in any case, please, you have my contact here. I hope that we can collect a lot of replies for our survey, and very happy to reply your questions and whichever need that you have from the project, that for sure it will give us a very good input.
Thank you, Jorge. Thank you for the very interesting presentation. I hope that you will share with the attendees the link for the survey in order for them to be able, to copy it and try to deal with that appropriately. I would also like to mention to Maxime as well as with you, Jorge, that there are quite some questions at the Q&A under the Publish tab in order for you to reply. I replied to a share of mine, and now I see that there's another one for me that I will revert. Let me just, randomly select one of them, Jorge, and ask you, we are talking about strengthening the competitiveness with autonomous shipping. Do we have any estimates of the cost? How much lower can autonomous shipping be against, I guess, the conventional shipping? Do we have a estimation, or is this the case? I mean, will it
this
be?
Is the case.
Yeah, go ahead.
Our idea is during the project we will test this demonstration use case, and we will know the competitiveness is very clear, because, for example, in a configuration of Europe, in where there will be a Eurovignette, in where the road transport is penalized, in where the logistics has a lot of limitations. For example, the time that you are spending to move cargo from A to B, crossing a port, try to stay in the port, try to be served in the port, and these kind of things. Also, the restriction during night for the work in the port terminals, etc. We have to make a lot of numbers on that. I cannot give you a percentage on this, but the idea is if we are resolving these limitations through the autonomous ship, there is a clear opportunity there, and we will see a lot of return of investment in the future. Of course, in the equation, you have to take into account the capex. Of course, it's a very smart vessel. There will be a lot of system exchanging information. There will be some system upgrading systems in the stakeholders involved. But for sure, we see that in the schemes that they are working in, the rest of people around the world, they are looking for this scenario in where there is a lack of seafarers on board. There is a lack of truck drivers working available to work, etc., etc. Those things give us an opportunity to really study the business case and try to adapt for those that are interested in studying it, the possibility to see the real competitiveness, the real incomes that we'll have in the future. But it takes time, and we are working on it.
Yeah, it's understandable. So once again, both Jorge and Maxime, please go to the Q&A, the Publish tab, and please try to reply to as many questions as you can in order, to complete the set of answers that is required by our audience. Thank you very much, Jorge. Let me just also remind to our attendees, please, at the Q&A, please put the name of the speaker you are referring at. So this will make, our life much easier. And at this point, I would very much like to welcome Dr. Matthew Macheras from MetroStar Management Corporation. Before giving the floor to Matthew, let me just mention and note that he is the Chief Information Officer of MetroStar Management Corporation. He holds a PhD in operational research from NTUA, I guess from mechanical engineer or chemical engineering department, Matthew, and an MBA from Imperial College in London. Matthew has a wide experience in managing innovative IT projects, typically involving cloud, Internet of Things, and AI. This is a very nice term. We focus on cybersecurity and data privacy. So, Matthew, the floor is all yours. We can see your presentation. Can you speak a little bit to be certain that we can hear you? Nope. Matthew has frozen. I do not. Yeah, I think that Matthew has frozen. Let's wait for 1 minute. Whether we can. Yeah, go ahead.
Temporary problem in connectivity.
Everything is fine now, so the floor is all yours.
Okay, thank you very much. And thank you for inviting me to this online conference. Very nice to hear esteemed colleagues before me. I'm here to bring the, let's say, user perspective by focusing on the theoretical and practical, the latest theoretical and practical developments in vessels autonomy, plus the developments in the regulations domain. So I start right away. So some parts of my presentation, I might repeat myself compared to previous presentations. Bear with me, but there's always new stuff as I update, as things go on. Okay. So start standard by saying a brief introduction to what is AI. AI, as we use it today, refers to a machine's ability to do automatically tasks, but not only doing them, but learning along the way on how to do them better without needing our intervention. So that's at the core of autonomy, but we should be careful. So AI is not yet general AI, so we shouldn't expect from machines like Gemini or ChatGPT to actually think like humans. And the same, of course, on board on the vessels. And this will be reached when the famous Turing test will have been passed without any doubt. Then we can start talking about human-level artificial intelligence. There are claims that this test has been surpassed. However, there are so many papers explaining that this is not true yet. And I remind to everybody that this is a test devised back in the 50s by the first people that wrote on paper about AI. And that's the paper that says that the Turing test has been surpassed, and another paper explaining that it has not. Coming back to the practical implications, whereas AI is not at human intelligence level, it's very good at prediction, and that's very useful for us, for our domain. That means that we can feed it mathematical models and lots of training data to generate prediction in all fronts. And how do we use it in maritime? Okay, I will start from the less fancy, from the bottom. So we have AI-powered solutions in the office that advance the knowledge worker, prepare things for us. We use it to optimize operations in the ports, and it's many times critical to also use it for autonomous vessels. For route optimization and fuel efficiency, together with carbon efficiency, that is more important than real money these days. For situational awareness and safety, which is already practiced massively on the vessels, and it's a step towards autonomy. And finally, on autonomous vessels and remote command system, as we saw earlier in our fellow presenters. What is the latest developments in marine autonomous surface ships? There are many advancements in AI and sensor technology. Computer vision has reached new heights, and machine learning is now at its peak of, let's say, productivity. It's not, it has left the labs and it's productive, used in everyday life. And we see many solutions out there. I know at least 3 of them, commercial solutions based on enhanced sensor technology like LiDAR and high-resolution cameras, and that also use real-time data from other systems like ICE and radar and weather reports to give you a totally updated view of the sea. We have many real-world testing and pilot programs, as we heard our colleague from the Russian front. There are many real-world testing and pilot programs, and we have a most impressive and regulatory developments and collaboration. Regulatory bodies, mainly IMO and IACS, the Association of Classification Societies, have gone on faster steps forward, as we will see. Here's the well-known roadmap, which has been partly revised this year, as we'll see, not in its major steps from autonomy level 0 to autonomy level 4, but in the targets that we have. Okay, among the testing and pilot programs, we all know the case of Yara and so many other projects, as I see here, that start to go into the fjords or other ferry routes. We have this US Army autonomous vessel, which is not acting autonomously right now, but it is equipped with the procedures to run without human intervention for 6 months, if needed. So that's one of the first, and it's in full operation right now. Of course, we have ferries going in the rivers and ports, and remote operation center, which seem to be the first real step towards autonomy. Let me pass quickly, as I already said, these. Yeah, short sea routes, etc. We heard a lot from previous presenters about towing and tug operations. Of course, that's another great field of autonomy. And let's focus on the change, on the regulations. There is already, as already my colleague said, a non-mandatory goal-based mass code to take effect in 2025, with a target to have a mandatory goal-based mass code to enter into force into 2028. All these are very close by now. Critical steps towards this are the legal sides, or the terminology and definition. What is master, crew, responsible persons, and particularly in third and fourth degree autonomy. We will see later that the first steps have been taken towards this direction from the recent FAL committee last April. And of course, IACS, the Classification Society International Association, fully supports the IMO steps and also publishes its guidance on the matter of autonomy as it starts to implement. Okay, so here's a summary of all the regulatory scoping exercise outcomes, and we see there are some of those that keep coming at a steady flow. We see we have 2021, 2022, and 2023. The good thing is that the plan is being kept, is not delayed, so we should expect further fast developments. And the most recent facilitation committee, FAL 48, last April, did a lot of work in revising the roadmap for autonomous ship and approved a revised roadmap. They had a special decision about safeguarding the cybersecurity of the maritime single window. I heard also many of the previous presenters talking about cybersecurity. And this is a good thing that it's now at the epicenter of the whole effort to know that it needs to be secure by design. And proceeded with industry survey of the current state of digitalization with ports and new IMO digitalization strategy, because digitalization strategy and autonomy go hand to hand. We cannot have autonomous vessel if not the environment is not digitized. And of course, new outputs on key workers designation, cyber risk management, and other things not relevant to autonomy. Given that chance, let me once again stress out the importance of cybersecurity that these days need to be AI powered, because the attackers are also powered by artificial intelligence. And as you saw, regulators stress this out, we stress this out as user, academia, and everybody stresses this out. And let me just pin out the recent development of having the first full ban of a cyber vendor. That was Kaspersky, fully banned in the United States with the rationale of geopolitical, let's say, danger. After some, reviews there have been, so that the stage is different these days. It's not a simple cybersecurity that we used to know it. It's also related to to geopolitical developments, and it's really serious and getting into critical and operational things. So the new Maritime Autonomous Surface Ships MASS revised roadmap, the committee is expected, the FAL committee, to assess the finalized non-mandatory MASS code by fall 49, which is planned for spring 2025, next year. Assess the adopted mandatory MASS code and consider proposed amendments to the annex to the FAL convention by fall 50, meaning 2026, and by the very next facilitation committee in spring 2027 to adopt any amendments to the FAL convention. So we see that there is a focus, and IMOs trying to keep the pace and be at least at par with the developments as we see in the various projects that you presented earlier, and the practice of the vendors out there. it is very important to see how it's the wording starts to crystallize, the terms that will go into legal effect when the autonomous vessels take place. So there is clear now that there should be agreed so far a human master responsible for any autonomous vessel. However, regardless the mode or operation or degree and level of autonomy. The thing is that the master may not need to be on board. So we could actually have a vessel without a master on board, but there is a master legally responsible for this vessel. Depending on the technology used and its certification, I might add, their levels of remote command centers should be certified in order to go into practice. There is a master. Regardless of mode of operation or degree, the master of an autonomous vessel should have the means to intervene when necessary. There should be a digital, even manual mode. Not digital, get your hands on it, but there should be a manual mode, not directed by AI or automation, let's say. Okay, two different things. That's why I said earlier, digitization has to go faster to have autonomy. Only a single master should be responsible for an autonomous vessel at any one time, although several masters could be responsible for an autonomous vessel on a single voyage under standard conditions, which means we could have a vessel crossing the Atlantic and have a master for the first half responsible, and then the master from the other side, from Europe, let's say, or from Africa, could take over. Or through the voyage, the masters could go in shifts, in 8-hour shifts or 4-hour shifts, and take responsibility of the voyage. So the old notion of having one master for each voyage and that's it could and should change for autonomy to go on. And there is discussion, that's an open discussion, if a single master could be responsible for many vessels, maybe in other applications like tugs or convoys of cargo vessels. There is this discussion that one master could be responsible for a convoy for many vessels. But this is, there need still many objections. So that's the most interesting so far and still developing. And that concluded my presentation. Thank you very much for the chance.
Thank you very much, Matthew. Very interesting presentation from a different perspective. I think it ran very smoothly and very complementary to what we have already presented. Due to time constraints, I will not ask you a question, but I will urge you to go to the Q&A session. I think that you will find I have checked and there are a couple of questions there for you. So please go and reply to our entities in writing. And once again, thank you very much for your presentation. He said this, we will pass to our last but not least speaker. We will have let's say the representative of Cibility, Mrs. Krikigianni, Eleni Krikigianni, who is the scientific project manager at Cibility. And before passing the floor to Elena, I would very much like to urge Elena, if she can, to to a little bit speed up the process. It would be more than welcome, Elena. And a few words on Mrs. Krikigianni. She has a significant experience in environmental engineering, transport planning, and security risk assessment. She has been involved in various projects, EU-funded projects, like a project manager, from Horizon Europe, H 2020, FP7 goes on. Her research interest includes sophisticated techniques of utilizing geographical information systems and remote sensing techniques, as well as the simulation and modeling of geographical data. Regarding application domain, she is mostly active in the field of environment, focusing on transport sustainability and ICT methodologies, logistics operation, freight transport, and port management. Elena holds a Bachelor in Engineering and an MSc degree in Urban Planning and Regional Development from the University of Thessaly. And she has also obtained a master's degree in geoinformatics from the Harokopi University of Greece. She also got an MBA from the National Technical University of Athens and University of Economic and Business, the Athens University of Economics and Business. A lot of degrees, Elena. The floor is all yours.
My new one is coming. So,
okay.
So hello everyone from my side myself. You heard Nikos earlier on talking about the autonomous tugboats in Moses. You heard also Javier. You heard also Matthew that highlighted LiDAR and high resolution cameras. So what I'm going to deliver in the next 7 minutes, I promise, is a presentation on the overall concept of Moses project, and towards also highlighting some application-specific innovations relating to autonomy. So next slide, please. So how Moses was realized. Next slide. Okay. So a few words about Moses. So Moses stands for Automated Vessels Supply Chain Optimization for Short Sea Shipping. It was a 3-year initiative supported by Horizon 2020 European funding program and granted 6-month extension. It was a research and innovation action of about 8 million euros with 17 partners across Europe. You can see the right-hand side geographical distribution, and it was coordinated by the National and Technical University of Athens. Next slide, please. So what was the idea and how Moses was realized? We first started by capitalizing on the statistics that said that almost 70% of imports and exports and almost 40% of exchanges were going through ports and are going through ports. So we consider ports as integral nodes with multimodal logistics flows using mainly road and mainly road and rail for backhaul, while the short sea shipping and the inland waterways are not so well integrated. And here Moses comes with its concept to enhance this short sea shipping component of the European supply chain by addressing the vulnerabilities and strains related to the operation of large container ships. How we did that? By employing a twofold methodology. For the short sea shipping leg, which was the one part of the methodology, we mainly focused on the ship design for sustainable services for ports that they have limited or no infrastructure. And for the deep sea shipping ports, we mainly focused on the technological solutions for reducing berthing time and improve the overall safety. Next slide, please. So here is the Moses concept. I will go very quick through it. So everything starts with a large container ship, what we so-called in Moses a mother vessel, top right of the image, which approaches a deep sea shipping port. Upon its arrival, it asks for assistance so she can be safely moored at the dock. The assistance is provided by the Moses Autodog system, which is a combined intelligent mega system that consists of 2 components: the Moses autonomous tugboat swarm for maneuvering and the Moses adapted auto-moor system kindly developed and offered by Trelleborg. So the Moses autonomous tugboats are dispatched and assist this container ship with the maneuvering process in a swarm and cooperative formation. The Moses tugboats are monitored through a remote control station located in these deep sea shipping ports, what we so-called Moses short tugboat control station, mid-right on the image. So the swarm of the tugboats automatically adapts their operation to the various environmental conditions and also to the potential orders that given by the pilot of the large container ship. As soon as, of course, the ship is the right position on the dock, the auto-moor system, which is with the blue rectangle between the mother vessel and the quay, intelligently communicates and cooperates with the swarm of autonomous tugboats in order the ship to be safely moored at the dock. Now, as the ship is safely docked, the containers loading and offloading process are starting. Here we may have containers that may need to be shipped to their destinations via hinderal connections through trucks or rail. And we may have also containers that need to be shipped in the near small ports. For the second case, containers are stacked by the existing port equipment near dedicated berths in the port and are loaded on the Moses innovative feeder vessel on the bottom left of the image, which is equipped, or how we say it in Moses, outfitted with a robotic container handling system, which provides semi-autonomous loading and offloading of the feeder. Both the feeder and the robotic container handling system are remotely monitored through a shore control center. It's on the left side of the image. Both the innovative feeder, while it is berthed at the deep sea shipping port, and the autonomous tugboats may use also Moses recharging station, which is an automated shore-based powering station for providing them power. As a result, now the feeder vessel goes to the near port that has limited or no infrastructure and starts the loading and offloading process. The whole, let's say, the whole concept is, let's say, somehow supported with the use of the Moses matchmaking platform, which handles efficiently the changing of the freight flows, the increase of the cost effectiveness of the partial cargo loads, and boosting also last mile and just-in-time connections among these transport modes, and of course balances the bulk haul traffic. This narrative is more appealing if you could visit also the available movie that we have on YouTube. I will also copy and paste the link in the chat right after my presentation. Next slide, please. So all these innovations within this 3-year initiative were tested in 3 pilot demonstrations. We have the first pilot demonstration in the port of Fraport, where we test the autonomous tugboats operation using trained algorithms. We also tested the auto-mooring scaled barges, and also we, let's say, tested the data transfer to shore tugboat control station at the port of Valencia. Then we conducted the second pilot demonstration back in September 2023 within the seakeeping and maneuver basing on Marine, where we tested the autonomous operation of a feeder vessel. When we talk about a feeder vessel, we talk about a scale model. And the third pilot demonstration was conducted back in September 2023, both in TNO premises in Soesterberg, the Netherlands, and in MacGregor facilities in Sweden, where we tested the autonomous cargo handling system. For all of these 3 demonstrations, there are, let's say, movies where we described each demonstration, and they are all available both in our website and on our YouTube channel. Next slide, please. Okay, let's see now what we have learned. Okay, we have learned a lot of things during these 3 years, but I think the making points about these kind of innovations. So we have the Moses Autodock. I remind you again that when we talk about Autodock, we talk about both autonomous tugboats and the Automoor. So what we have learned is that the incorporation of autonomous tugboats can significantly reduce the maneuvering and docking times in the deep sea shipping ports over than 20%, that the reinforcement learning produces tugboat movements similar to manually operated tugboats. The tugboat position accuracy less than 1 meter, and of course the communication between between the tugboats and the automated mooring are considered crucial factors, as you may understand. Human in the loop seems to be the way for safety critical operations. Professor Vedikos talked about that in his presentation. And integration with existing control systems is still challenging due to the highly interoperability issues, not only in our domain, in every domain in general, but here it applies also as well. Next slide, please. Going now to the next set of innovations, which consist of the Moses feeder and the robotic container handling system, is what we have learned here is that significantly lower cargo capacities are more cost effective comparing to the conventional container feeders, that the hybrid power solution was estimated to have 10% lower operating costs compared to fully electric. Charging also a fully electric feeder at the large container terminal, what I said in the deep sea shipping port, it is technically and economical feasible. We conduct a feasibility analysis here. The fully autonomous port-to-port operation is technically feasible and could be an advantage, of course, due to less human resources required. And last but not least, the automated crane may be faster by 25% than the human-driven crane, compared to the conventional ones. It can also give the chance to small ports to be included in the supply chain with near zero investments. Next slide, please. Okay, of course, we have learned a lot, but there is still room for improvement. So the challenge is ahead, and some food for thought and future research is also highlighted as part of the results and the concluding remarks of our project. So in terms of the Moses Auto Dog, future research may be focused more on safety studies for autonomous operation, introducing failure rate training, like Nikos mentioned in his presentation. Also, they may be focused on increase the scope of training scenarios in different conditions like weather conditions, port traffic, nighttime operations. And of course, it is of great importance, the real-time integration in port operations. As about the Moses feeder vessel and the robotic container handling system, again, the future research may focus on safety studies for autonomous operations. And of course, to test also the reliability of the robotic container handling system and its behavior in extreme and harsh weather conditions. So that was, in a very fast track, my presentation. If you have any questions, you can always find us on our website, on our social media. We reply to every request, to every mail. We have more statistical, let's say, results that are going to be uploaded in the next months. They're going to be publicly available through our deliverables. And thank you very, very much for attending. And Nikos, the floor is yours.
Thank you, Elena. Thank you very much for shortening a little bit your presentation, but it's more than welcome. At this point, let me tell you that I think there are a couple of questions. I see some new questions on the chat. If you can go there and reply, so our attendees, the people that are asking, they can get your short reply. And at this point, I think, first of all, it's very nice to see that even we are a little bit late, there's still about 100 people attending this online session, and thank you very much. We will be trying to answer in writing all your questions in order for you to have a complete set of replies, as I mentioned earlier. I would like, of course, to thank our presenters. I'm certain that all of your presentations were very well accepted by our attendees. You see that the audience posed a lot of questions. I believe that they were quite complementary, the various presentations with each other. So I would like to thank Maxime from Marinet, Jorge from Fundación Valencia Port, Matthew, Dr. Majeras from Metrostar Management Corporation, and of course, Elena from Cibility. At this point, I would like also to thank the BS Group as the organizer of this online event, of the third Autonomous Ship Reality online session, and our sponsor, Marinet organization, for supporting this kind of activity. I would like, gentlemen and lady, to thank each one of you for your contribution. I would like, of course, to thank our audience that they are still with us and they are still posing questions as I see, and hoping that I will see you and talk to you in the imminent future. Thank you very much, and thank you for attending this online event. Thank you very much.
Thank you all.
Thank
Have
you.
a nice
Thank
afternoon
you.
ahead,
Cheers.
all of you.
Cheers. Bye-bye.